Welcome. In this video, let's talking about the Boolean algebra. First part, we are going to talking about Boolean operator. Boolean algebra. The name honors of the English mathematician George Boole, who proposed the basic principles of this algebra in 1854. What is a Boolean algebra? Boolean algebra deal with binary variables and logic operations. Boolean operators including AND, OR, NOT, exclusive OR, NAND, NOR. The combination of the variables and operators is what we call Boolean expressions. Boolean function is described by an algebraic expression. For example, here, this part is f, x, y, z. This is the variable, and this part what we call the Boolean function. And x, or y complement, and z, this part we called Boolean expression, and this is the whole equation. Let's look at the logic operator. AND operator represented by either a dot or simply no symbol, referred as a Boolean product. Here, variable x and variable y, we can represent x dot y, or it's just a simple x, y. The operator OR represented by a plus sign, referred as a Boolean sum. So x or y equal to x plus y. This is the same representation. Not represented by a over score. Here is over score or over bar, or a prime. So not x is equal to x bar equal to x prime. This is the way to represent these operations. Let's look at the truth table about all these operators. AND operation here choose if and only if both of the operands are true. So the both sides x and y are equal to true, and then the AND is going to yield a true. Or yield true if either or both of its operands are true. So the either side, x and y, either side has a 1, and then the OR is going to be 1. Not reverse the value of its operand. So 1, the x is a 1, and if you take the not operator, not operation, it's going to be 0. Exclusive OR yield true if and only if exactly one of the operand has 1. So if x is equal 1 and y equals 0, exclusive OR is 1. If both x and y equal to 1, that is still 0. So only exactly one of the operand has 1, you are going to get the true. That is exclusive OR. NAND, not AND, is a complement. It's just reverse the AND function. So if AND result equal 1, and non-AND is going to reverse to 0. Non-OR is also the complement of the OR result. It's just a reverse the result of the OR. Okay, for easy understand to look at this truth table, so the variable A, variable B, here the A and B is both 0, 0, 1, 1, 0, 1, 1 for the variable. And let's look at A and B, so we can represent A dot B. So both side is 0, and then it's going to be 0. If either side is 1, and then this is going to be 0. And either side is going to be 1, is going to be 0. So both sides is the 1, and then that is the 1. So basically, and means both sides need to be exactly the same. If the both of 0 is going to 0, if both of the 1 is going to be 1. If either of the 1 is going to be 0. Or is represent A plus B. So A or B is, since both sides is 0, is going to be 0. And there's B is a 1. So either A or B has 1 is going to be equal to 1. So the A is 1. So that is also 1. Both sides 1. And the result is 1. So this is the OR, exclusive OR. This is the representation of the exclusive OR. This is the symbol. It's plus with a circle. So only case only exactly one side of the variable equal 1, and then it's going to be 1. Otherwise, if both sides exactly the same, going to be 0. That is exclusive OR. Not is easy to understand, just the reverse. So not A reversed A 0, 1, 0, 1. If the 1 reverts to 0, if the 1 reverts to 0. A non B, so A and B and reverse. A and B is 0, reverse to 1. A and B is 0, reverse to 1. A and B is 0, reverse to 1. And A and B 1 is reversed to 0. So A nor B, so A or B reverse. This is the bar is going to reverse. This is the OR. So if we got the OR 0, revert to 1. If we got OR is 1, revert to 0. Is 1, 0, 1, revert to 0. Okay. This is the operation of the two variables. We get this choose table. There are some rules for processing binary operator. Who is going to be the priority? Who is going to be the first one? So basically we follow these rules. Not is going to the top priority, and then the followed by the end. Then the OR is the third position. For example, this function, and this is Boolean expression x or y complement and z. So in this case, we are going to calculate this y's complement first. So negate y first after the reversed, and then we calculate this AND operation. So then perform AND of the y's complement and z. After finish this part, the final step is going to calculate this OR. So final going to OR the result with X. Okay, here this is the chart what we do. So if 3 zeros for all these 3 variables, calculate the y's complement first. So y0 complement 1, and then calculate this the y complement. So add, since this is the 1 and 0, that's going to be 0. The last step is this part or x or this part. So x is 0, this y's complement and z is also 0. So 0 or 0 is 0. Let's look at another situation. If the x 0, y is 0, and z is 1, so to do the y complement first, so the y is 0 and reverse to the 1, and then the 1 and 1, that is 1. So 1 or x 0, so 0 or 1, the result is 1. Okay, this is the rule for the priorities to do the operation. Okay, I'm stopped at here for the basic concepts for the Boolean operations. And then thank you very much. See you next time.